So today I will be talking about going beyond retrieval augmented generation to all the different tools and techniques you'll need to build a reliable AI system for privacy tasks. So it's only a 10-minute talk, and I know after yesterday that's going to go really fast. So I'm going to blitz through a ton of material and then can always follow up with you all afterwards if you want to go in more depth. But we're going to start with the problems. Why use AI to solve privacy problems? What are the capabilities and limitations of AI today? Go into an overview of what retrieval augmented generation is, and then all of the next steps beyond that. So tool use, hallucination prevention, output normalization, things like that. And then at the very end, I have a slide on where I think the industry is going from an AI perspective, privacy perspective, and what some of the existing limitations are that hopefully will be no longer as foundation models progress. So I wanted to start by polling the room. Who here is using AI in some form at work today? Pretty good. Who's using it just for like content generation? So like email writing, doc writing, editing, stuff like that. Okay. What about code generation? So like code reviews, debugging. And who's using it for privacy tasks specifically already? So PTAs, PIAs, things like that. Okay, like some scattering. So this is a news article that came out 2 months ago now, where the Shopify CEO told everyone they had to use AI before trying to get new headcount. This is a constant push that's been happening from a top-down perspective across many different industries of saying, hey, you need to use AI for your work. But you shouldn't always use AI. So wanted to quickly contextualize, like, when should you apply AI to different problems? As a hammer might think everything is a nail, we should stop and ask ourselves if it's actually an appropriate application, or are we just excited to use our new hammer? So AI is really great at characteristics that require understanding of diverse context types, code bases, documents, image, rich contents. The squishiness of LM inputs makes it really good at having a variety of input source data. It also requires taking that context and transforming it into some normalized output. And so it's also a computer. It's great at well-defined, consistent workflows and frameworks. It can handle scale and repetition. Unlike your privacy engineer, they don't get tired, they don't get hungry, they don't ask for more pay, they have infinite patience, and they can process in parallel, in response, on a schedule, et cetera. When should you not use AI? Tasks where there's unclear process, the process has not been defined yet. That is your job as the privacy engineer to decide what the process even should be and should look like for your organization. Tasks requiring significant trade-offs when there's no clear right answer. It could be a yes in some cases and a no in others. There's major business trade-offs. You have to take in input from many different stakeholders. That should still be done by a human. And tasks where probabilistic outcomes are not tolerated. At the end of the day, all machine learning models are probabilistic systems, which means that they're non-deterministic, and therefore, 99.99% of the time they might answer one way, but there's still a probability that they'll answer a different way in that 0.001% of the time. If you need it to always be the same, you should use a deterministic system, not an LLM. So before we go beyond, is everyone familiar with what retrieval augmented generation is? Raise your hands if you know what RAG is already. Good, okay, I don't need to spend that much time on this. Basically, the big difference between just using LLM out of the box and using retrieval augmented generation is that you have some retrieval component where you're going and retrieving information from a source location. The traditional RAG is you have a bunch of documents, you go through a chunking process where you break the documents up into little pieces. You then use embeddings to encode them into a bunch of vectors that each encode the meaning of those chunks. You put them into a vector store, and then you use vector search to search across the vector store in order to find the relevant chunks for the thing that you're looking for. You then return all of those relevant chunks into the context window of your large language model in order to give it the information that it needs to make the final determination. The problem with this is that when you then get those source chunks or snippets, they end up looking a little bit like this. Pretty opaque. Sometimes they even say like source chunk 1, source chunk 2. Not super useful. So when we really think about going beyond RAG, the first big step to take is tool use. This is also called function calling by some API providers, but at a high level allows you to use APIs to programmatically search internal systems, the webs, call other agents, et cetera. So this is really RAG 2.0. The best thing about tool use is that it allows for like full programmatic parsing and calling APIs as you would normally, which means that you can trust the responses out of it. You don't necessarily even need to send it back through a generation component at the end, which allows your responses to be more grounded and can really help against the number one thing that plagues, in my opinion, privacy engineers about LLM systems, which is hallucinations. So when I think about building a reliable AI system, the first thing I think about is preventing hallucinations. And there's a bunch of ways to minimize hallucinations today, tool use and function calling being one of them. A few others are things like chain of thought reasoning in order to improve explainability. It also helps, you can find that LLMs actually come up with better answers when they have to explain their thought. It's the same idea as a elementary school math student being asked to show their work. It actually helps them arrive at the right answer by going through the process of showing the work. Doing prompt engineering can do a ton from a hallucination prevention perspective, just changing the way that you're prompting the model. One thing that we found is LLMs really like to be right. They like to be able to respond to a question and have an answer when they're asked. And so having information in the prompt that rewards them from saying, I don't know, is a great way to prevent hallucinations. Just giving them the permission that when they're called on in class, they can say, I don't know the answer, is huge from their ability to no longer hallucinate the answer, which is the same kind of idea as if you had a Socratic method class with a bunch of college students. Like giving them that permission to say, I don't know, makes them much less likely to make up an answer. LLM is judge. So this one actually have a very hard to read code slide. But basically, this is using an LLM call to evaluate other LLM calls. So what this one is doing is it's a claim extraction call. So what you're basically doing is you will take the response from the large language model, and then you will take all your source information that you use to generate that initial response, and you will perform a claim extraction to say, okay, if the large language model says that there is a linkage attack between these three different types of data that allow us to determine who the person is, you want to break down that sentence into all the individual claims that were made out of that sentence. So what are the three pieces of data? How are they all shown that they're linked together? How can you actually prove that that is connected to identifying an individual? So that will break it out into 10 or 15 different micro claims. And then for each of those claims, is that claim substantiated in the evidence that you initially provided the LLM? And if it is, then that's great, there's no hallucination. But if it's not, that shows that there was a hallucination present, and you can use that to further tune your large language model. Next up, output normalization. So the overall goal of output normalization is to get consistent, actionable, and grounded outputs. Basically, that really allows you to use LLM-based systems in connection with traditional function-based systems and APIs. So basically, if you want to use a large language model and have it return a Boolean output, yes or no, you can't actually guarantee that unless you use structured output. You can try to, with prompt engineering, be like, hey, only respond yes or no, but then the model will sometimes be like, yes, and that won't be easy to encode into like a Boolean, like Python variable. So what we really recommend is using different types of output normalization tools. The one that we use at Clearly is called BAML, which stands for, I don't know. It's like, I think the not safe for work version is basic ass machine learning, but it is yet another markup language that is meant for specifically prompting large language models. And it's large language model agnostic, so you can use it across any different type of model. It allows for smart fallbacks to different types of models if one model provider is not available for whatever reason. And it allows you to actually structure all of your outputs directly into variables. So you can use it, we use it embedded in Python code so that each of these variables that I define inside this personal data type are then accessible in my Python code outside of BAML. And I can use that directly in future function calls. So it allows you to take what can be a very squishy response from a large language model and make it structured and usable going forward. Okay, finally, a lot of people have been like, hey, but what about fine tuning? The answer is, you can go really far without having to do any fine-tuning. At some point, you may need to, once you have prompt engineering and retrieval augmented generation and all of the other tools and tips that I've covered in this talk, but that should be a last step and not a first step. So when we think about kind of going beyond RAG to all the other advanced forms of AI engineering, fine-tuning is the thing that takes the most time and the most money and is the least likely to pay off. And there's a lot of reasons why that I can go into in more depth if you catch me afterwards, but there's so much you can do before you have to do any training of a model on any customer's data, which is great for you all as privacy engineers to push your engineering team to say, do we really need to fine-tune? Do we really need to use customer data to tune this model? Highest likelihood you can use it, inject it at the inference time so that you're not training on people's data. Now that I've sprinted through a bunch of AI engineering techniques that you can use for privacy tasks to make your AI applications more reliable, let's talk about some of the challenges. Key challenge, garbage in, garbage out. I'm sure you've heard a lot of people say this. Different pieces of evidence have different amount of trustworthiness. Big thing that we're using now is a concept of evidence weighting. So being able to weight the reliability and the trustworthiness of different sources of evidence. So code, high trust evidence. Someone's design doc, medium trust evidence. A vendor questionnaire, low trust evidence. You never really know what they put in there. So trying to be able to do different evidence weighting depending on who the source is. You can even say, hey, we know this engineering team doesn't really know anything about privacy. Let's lower the trust that we have in the evidence from them and raise trust in their embedded privacy engineer or privacy champion. And so you can kind of tune that. Misinformation. So this is like a key challenge that continues to happen as far as people's understanding of how AI systems work. I think that there needs to be a lot of changes when we think about the future of AI and privacy into the people that are making the laws, the regulations, the AI guidance, actually understanding the fundamentals of how the AI systems that you're using work. So I'm glad you're all here, but continue to get educated and use the tools. Like you may have formed an opinion about ChatGPT 2 years ago. It is not the same product. It is not the same model. It is so, so different. Like you should be revisiting it. It is a completely different paradigm at this point. Also, human in the loop, that continues to be a challenge. Automation should be a support, not a replacement. You should push people to have humans in the loop at the right time. And another challenge kind of moving forward is being able to tie things together. So AI automation for one privacy task, how does that feed into future privacy tasks? What does it mean if there's a mistake made upstream? How can you correct for it downstream and add future guardrails? All right, I think I'm at time. This is the part of the talk where I acknowledge that this is my first PEPR where I'm technically a vendor instead of a practitioner. I personally hate technical talks that try to sell you tools. So my goal was instead to equip you with everything you need to build AI-powered automation in-house. If you scan this QR code, you get all of our AI engineering tool recommendations. Most of them are free and open source. Notations for open source, free tier, companies with better security and privacy commitments, and things like that. So hopefully this is helpful. I think that everyone should have their hand on in building AI tools. So hopefully this gets you part of the way there. And that's it. Thank you.